In this video, you will continue learning how to simplify a trigonometric expression. First thing I'd like you to recall are the steps that are usually used in order to simplify an expression. Start with any co-function or negative angles. Once you have done all of those, you should be looking for some Pythagorean identities. Usually these will be two terms you're trying to make one. Next, if there are any fractions, you might want to get a common denominator and make them one term. Next, if there are any common factors such as a GCF, I would take those out. And a last resort is to always put everything in terms of sine and cosine. This usually means using the quotient identities of changing tangent to sine divided by cosine, or changing cotangent into cosine over sine. Let's take a look at number one. In this first trigonometric expression, we can notice that we have a co-function identity. Right here, the sine of pi over 2 minus x is the same thing as the cosine of x. We still have that multiplied times the tangent of x. If I go down my list, there is no Pythagorean identity. I do not have any fractions. I do not have a common factor to take out. And so I'm left with changing things in terms of sine and cosine. Cosine is obviously already in those terms, but tangent is not. If I use the quotient identity, I can change tangent to the sine divided by the cosine. If I multiply these fractions straight across, I end up with one fraction of cosine times sine divided by cosine. Since this is multiplication in the numerator, anything divided by itself simplifies to a value of 1 and cancels out. And so 1 times the sine of x is the sine of x. Since that is one term, I am fully simplified. Now let's look at number 2. There is no co-function or negative angles. But if I look, there are two terms. They are squared. This is actually our original Pythagorean identity, and therefore simplifies to a value of 1. That's all there is to be done. Let's now move on to number 3. In number 3, again I'm going to notice there are no co-function or negative angles. At this point there is no Pythagorean identity, but there is a fraction. So one thing I would recommend is you could get a common denominator and make this one term. But one thing I'm noticing about this fraction is that I could easily get rid of the fraction by doing one of the reciprocal identities. 1 divided by sine is the same thing as cosecant. And so if I just use the reciprocal identity, I no longer have a fraction. So now again I want to go to the top of my steps. Still no co-function or negative angles, still no Pythagorean identity, no fractions, but I do have a common term in each term that I could factor out. If you factor out this GCF of cosecant, you're going to be left with something multiplied, well, it will actually be one of our Pythagorean identities. The way I factor this GCF out is I'm going to take each of the original terms and divide them by my GCF. In the first term, that leaves us with cotangent squared. And the second one, I'm left with the value of 1. Remember, anything divided by itself is 1. Again, if I go back to the top of my steps, no co-function or negative angles, but cotangent squared plus 1 is one of our Pythagorean identities. That's the same thing as cosecant squared. So I can replace those two terms with the one term cosecant squared. Then multiplying cosecant to the first times cosecant squared, I add the exponents and get cosecant cubed. Because again, that's one term, I know I'm done. Let's now move on to number 4. In number 4, I notice right away that I do have a cofunction. Cosine of pi over 2 minus x is the same thing as sine. So I want to replace that first denominator with a sine of x. There's not a Pythagorean identity at this point, but now I do have fractions. And so I want to get a common denominator so that I can combine these two terms into one fraction. Unlike number 3, I do not have a simple reciprocal identity that will get rid of the fraction. So, one way that I can do this is if I look at the denominator of the fraction I have, I want to take the other term and multiply both the numerator and the denominator by that value. That would give me the common denominator I need to be able to combine my fractions. Now, because both fractions have a sign, I can combine it into one fraction, adding the numerators. At this point, I have done all the simplifying I can with that step of getting a common denominator, so I want to look at the top. Again, there's no cofunction or negative angles, but I actually do have a Pythagorean identity in the numerator. Cosine squared plus sine squared is the same thing as a value of 1. So I can replace my entire numerator with a value of 1, and then 1 over sine is the same thing as cosecant by the reciprocal identity. Again, I have one term, so I'm done. At this point, please pause the video and complete number 5 on your own. When you're done, check your answers with the video. In number 5, I'm going to notice right away in the numerator I have a Pythagorean identity, and in the denominator I have a Pythagorean identity. Let's start with the numerator. 1 minus cosine squared of x is the same thing as sine squared of x. Now, if I look at the denominator, secant squared minus tangent squared is the same thing as 1. And since anything divided by 1 is just itself, this expression simplifies to sine squared x. Please now pause the video and complete number 6. When you are done, check your answer. Starting off in number 6, we have a cofunction identity. Cotangent of pi over 2 minus x is the same thing as tangent. At this point, I'm noticing that tangent and cotangent are reciprocal identities of each other. And so if I change either one of them to its reciprocal, and then multiply my fractions straight across, I get a value divided by itself, which leaves me with 1. Please now complete number 7. When you are done, please check your answer with the video. In number 7, the only thing I can do if I go through my steps is change tangent to be in terms of sine and cosine. Since tangent is the same thing as sine divided by cosine, when I multiply these and combine it into one fraction, I'm going to be able to cancel the cosines, leaving me with sine plus sine. Here I'm essentially just combining like terms, and so 1 sine plus 1 sine is 2 sine theta. Again, you have one term, so you know you're done. Let's take a look at number 8 together, because this is a little different. If I go through my steps, the first one I'm going to notice I can do something with is fractions. We have a fraction here, and so we could get a common denominator and combine it into one fraction. I actually think on this problem that's a little bit more work, and I want to show you something else. So what I'm going to do is I'm going to change everything in terms of sine and cosine. Again, if you don't know what else to do, you can always start there. So tangent is the same thing as sine divided by cosine. Because it's tangent squared, I'm going to make it sine squared divided by cosine squared. Then secant squared would be the same thing as 1 over cosine squared, and cosecant squared is the same as 1 over sine squared. Now what you're going to notice here is that I have a fraction within a fraction. You always want to simplify that and get rid of it so that there's just the one fraction. The way we do that is by multiplying by the reciprocal of the denominator. Here, that's going to be sine squared. When you do that, the denominator will always completely cancel out, leaving you with just the numerator times that reciprocal. And of course, we still have our sine squared over cosine squared. If I multiply those, you're going to notice that you actually get sine squared over cosine squared. And anything minus itself is a value of 0. So this actually simplifies to a value of 0. But again, what I wanted you to see here was how to get rid of a fraction within a fraction. Remember to multiply by the reciprocal of the denominator. Please now complete the worksheet for day 2.